Yes, and there's the first question which directly fits into our topic, which we're on. Do you think there will be an ABI break in the future of C++?
I think there has to be. Because the whole concept of what C++, the obvious thing, C++ grew from C. C has a very simple, conventional idea of what an ABI looks like historically, and so it's at a very primitive level. What is needed but the thing is that C++ is not simply C with classes. We've seen the problems with this in trying to get separate compilation for templates in the first time around in C++ 98. The template model was not simply just a few generics in a simple fashion. It actually changed the model of the language. If you've ever tried to debug templates, you will know that that is still not satisfactory in 2023 compared to, and certainly error reporting, because it still, most compiler models or mental models people have operate off the idea that it's just a procedural language and errors happen in one place. If there is a compilation error, it happens in one place. Now, what's this got to do with ABIs? Well, quite a lot, because the whole thing is, what do you need from the language? The original idea is, if I have a syntax error in a traditional procedural language, that syntax error is in one place. There is only one thing that could possibly be happening if you're calling something. You are calling a function. In C++, you could be doing any number of things. The language has built on top of this very rudimentary, simple idea. And what it needs, and particularly when we start including a proper discussion of things like modules, proper discussion of dynamic linking, a proper discussion of some of the things that we want. And one of those things when people say, if we design this from scratch, if we designed it again, we'd do it differently. The gap between what is available now and what the language wants to be. I mean, C has not moved very far from its starting point in this. I think we have to have some kind of breakage. I think it has to be, I think we have to have a, for the various platforms, a version 1 and a version 2, as simple as that, or an idea of ABI evolution. But I don't think, I think the fact that ABIs are non-standard, or rather are set by a particular historical precedent, and don't mix well and can't evolve, is going to stand in the way of a language that is supposed to be a systems language. That's its origin. It's a systems language. It's supposed to be portable. And that used to just mean source code portability. We don't live in that world anymore. And so there has to be, I think, I don't think C++ is going to disappear overnight. That's not going to happen. But when people start saying, we could do a better job at this level, and they choose another language, then that obviously will push it down a bit. So I think there has to be that, if it's going to be serious about being a systems language that people can use for what we mean by modern portability or modern architectures. And avoiding the ABI question is not helping C++.
I do think we need to address that. And there was a very interesting paper coming up with a standard way to address that, that you could define code blocks as interfaces, and then basically say this code block is valid from either you could use a standard version, like this code block is only valid for C++ 23 account, or you could like define your own versioning. Like if you're like a library and you want to say this code block is for version 2, for version 1.1, and that way you would be able to compile down the same code base into different versions and have like kind of everybody be happy. And I think that would be something interesting to have in the library.
I think that has to be the way of it, because we've seen the language has evolved. The hardware architectures and operating systems we work on have evolved. What we mean by modern software architecture has evolved. But if the ABI doesn't move, that becomes ultimately a bottleneck, and you end up with an ABI that consists of workgrounds. So that's how to think of it.
I mean,
yes, that's it. That's how it is.
It's not theoretical what we're talking about. It's this if you're worried about like caching effects, shared mutex on Windows is smaller than the normal mutex, because the normal mutex still had, in its original implementation, and it's stuck in this ABI forever, supporting Windows XP. And it could be a lot smaller. And on Linux with GCC, it's a lot smaller. But on Windows, the shared mutex is in the memory footprint a lot smaller than the standard mutex, and stuff like that is.
So we end up being stuck with experiments of the past. We prevented evolution and therefore prevented improvement, even though everything else around it is improving. The underlying platform could do better. There are compilers that could, if we broke that, you could do everything better. So I think perhaps a different way of answering the question is, do you think there'll be an ABI break in the future? I think let's look at it from a different point of view. It's like kind of yes, but also I think we need to approach it philosophically. I don't think breaking one and then moving to another is the answer. We should learn the lesson of like, oh, it's always going to change. That's the lesson. It's always going to change. How do we accommodate change? And that idea of being able to target things differently, I think, is incredibly important, because change is one of the few things that is normal. And we now know this is a thing. We should accommodate that.
So